Applications of linear equations. So there are 7 steps to solving word problems. The first is to underline or highlight all given information. So we're going to do them step by step for number 1. Cassidy has a brother who is 3 years younger than she is. The sum of their ages is 23. How old are Cassidy and her brother? So we need to determine what we want to find out. So we need to find out how old Cassidy is and how old her brother is. So this is, what do we need to know? Draw a picture if we need to. I don't really need to draw a picture for this one, but we can write some let statements. So let C stand for Cassidy's age, and let B stand for brother's age. So now we're going to write some equations. So Cassidy has a brother who's 3 years younger than she is. So Cassidy's brother is 3 years younger than Cassidy. So Cassidy's age minus 3. The sum of their ages is 23. So Cassidy's age plus her brother's age is 23. So what we're going to do is we're going to take this C minus 3 and we're going to put it right here. Because notice that I have B equals and I have a B, so we can just plug it right in. So I have Cassidy plus Cassidy minus 3 equals 23. Well, 1C and 1C makes 2C minus 3 equals 23. I'm going to rewrite this equation over here so I have more room to solve it. 2C minus 3 equals 23. And we're going to solve this like it's a two-step equation. So add 3 to both sides. 2 times Cassidy's age equals 26. Divide by 2, and Cassidy is 13 years old. So Cassidy is 13 years old, which would make her brother, if I take 3 years off of that, is 10 years old. So I solved it. Now I need to check it. So in order to check it, you go, does 13 plus 10 equal 23? Yes. Is 13 minus 10, or is 13 minus 3 equal to 10? Yes. So it is checked. Jared has pennies and dimes in his pocket. The number of pennies is, so pennies is 3 less than 2 times dimes. If he has a total of 46 cents, how many pennies and dimes does he have? So we need to write our let statements. P is going to stand for penny, and D is going to stand for dime. So we have the number of pennies. So pennies is 3 less than 2 times the number of dimes. So 2 times the number of dimes minus 3 is the number of pennies. And then we know that we don't know the number that we have total, but we know how much it costs. We have to think about how much is a penny worth. Well, a penny is worth 0.01, and a dime is worth 0.10. And we know that altogether it equals 0.46. So we're going to take this 2D minus 3, and we're going to plug it in for the number of pennies. Since pennies equals that amount, we can put it directly in for pennies. So 0.01 times 2D minus 3 plus 0.10D equals 0.46. So we can do the distributive property. 0.01 times 2 is 0.02D. And 0.01 times 3 is 0.03. Plus 0.10D equals 0.46. We can combine like terms. So I have a positive 0.02D and a positive 0.10D, so that becomes 0.12D minus 0.03 equals 0.46. And we solve our two-step equation. So add 0.03, add 0.03. And I now have 0.49 is equal to 0.12D. Divide both sides by 0.12. And our number of dimes is problem with this is going to end up being a fraction. It's approximately 4. So then if I were to plug 4 back in, I put 4 in for this d up here. 2 times 4 is 8. 8 minus 3 is 5. So the number of pennies would be 5. If I look at this, it wouldn't end up checking because this did not end up being a full number. It was 4 point something. So this one does not make sense. So this one does not have a solution. So no solution that works perfectly for it. The greater of two numbers is 1 less than 3 times the smaller. So the greater of two numbers is 1 less than 3 times the smaller. If 3 times the greater number is 5 more than 8 times the smaller, find the numbers. So we need to write let statements. So our let statements is G is greater and S is smaller. Because we're talking about two different numbers, a greater number and a smaller number. So the greater is, anytime you see the word is, that means equal. 1 less than 3 times the smaller. So 3 times the smaller minus 1. And then if 3 times the greater number is, again that word is, 5 more than 8 times the smaller. Now we can take this 3s minus 1 and put it in place of this g. So I have 3 times 3s minus 1 equals 8s plus 5. So we do the distributive property. So 3 times 3 is 9s. 3 times negative 1 is negative 3, and that's equal to 8s plus 5. And we're going to solve with a multi-step equation. So we subtract 8s from each side, and now I have s minus 3 equals 5. I'm going to rewrite it up here. So s minus 3 equals 5. Add 3 to both sides, s equals 8. So if s equals 8, then g is going to be 3 times 8, which is 24, minus 1, which is 23. If I were to check it, is 23 equal to 24 minus 1? Yes. And 3 times 23. Let's think about 3 times 23. So 3 times 23, is that equal to 8 times 8 plus 5? Well, 3 times 23 is 69. 8 times 8 is 64 plus 5, which is 69. So yes, that works, and yes, it makes sense. All right, we're going to talk about sides of a square. So this one is one of those where you will want to draw a picture. Two opposite sides of a square are increased by xm. The other two sides are decreased. So this one, the number is increased by 3. And the other one, it's decreased by 1. And we know that the perimeter is 40. So we're going to write x plus 3 plus x plus 3 plus x minus 1 plus x minus 1 is equal to 40. So we need to combine like terms. Well, I have 1, 2, 3, 4 x's. And then I have 3 plus 3 is 6, minus 1 is 5, minus 1 is 4. So positive 4 equals 40. If I solve this two-step equation, I get 4x equals 36, so x equals 9. But I need to find the length of a side of the original square. The original square is x, because the original square would be x, 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 and x. They changed it by adding 3 or subtracting 1. So we're going to talk about consecutive integers. If x is 5, how do I get to 6? Well, I add 1. And to get to 7, I add 2. Now let's look at even integers. If x is 4, how do I get to 6? Well, I add 2, and to get from 4 to 8, I add 4. And for odd integers, if x is 5, I have to add 2 to get to 7, and add 4 to get to 9. So even though it is odd, you're still going to add 2 and add 4, because that's not talking about the number being even or odd. It's talking about skipping the even numbers to get to the odd. So find two consecutive integers whose sum is 45. So my first integer is always going to be x. My second integer, if I'm talking about consecutive, it'll be x plus 1. So now I need to take these and add them together to get to 45. So x plus 1 is 45. So 2x plus 1 equals 45. Now we combine, or we solve a two-step equation. So subtract 1, and 2x equals 44. Divide by 2. So our original x is 22. So if my first one is 22, then my second one has to be 23. To check to see if we did it right is to see, is 22 plus 23 equal to 45? It is, so it's true. Now we're looking at three consecutive even integers. So my first number is always x. My second, we're talking about even integers, so we don't want to do plus 1, because if x was 4, 4 plus 1 would be 5. So we need to do plus 2, and my third is going to be plus 4. So the sum of the smallest, so my smallest is x, and its sum, and 3 times the second. So 3 times the second exceeds twice the third by 28. So this sum exceeds twice the third by 38. So meaning that this answer is 38 more than twice the third. So combine like terms. I have x plus, we need to do distributive property. So 3x plus 6 is equal to 2x plus 8 plus 38. We need to combine like terms. So 1x and 3x makes 4x plus 6 and 2x plus 46. We need to solve a multi-step equation. So subtract 2x from each side. And now 2x plus 6 equals 46. Subtract 6 from both sides. So 2x equals 40. Divide by 2, and x equals 20. So if my original is 20, and they're consecutive even, then 20 plus 2 is 22, and 20 plus 4 is 24. For each equation, you're supposed to work with a partner to find the solution. So what I want you to do is actually work through each one of these on your own, and then when you're completely done, go ahead and check the answers that I have. So pause it as needed. So the first one, we want to start by doing the distributive property on the right-hand side, because the left-hand side, we don't have anything to work with yet. So 2 times x is 2x, and 2 times 6 is 12. So looking at that, what you do first is you move the variable. So we're going to subtract 2x from each side. The problem is, once you subtract 2x from each side, you no longer have an x on either side. You just have 4 equals 12. Well, 4 can never equal 12, so this one is no solution. The next one, we first need to do the distributive property. So we do the distributive property. 4 times x is 4x. 4 times negative 3 is negative 12, equals 6x plus 8. So unlike the first one we just did, they do not have the same variables on each side. So we can subtract 4x from each side, and we will still have a variable to work with. Subtract 8. Now on this left-hand side is where a lot of people struggled on the last quiz. This is the same thing as negative 12 plus negative 8, which makes negative 20. Now to figure out what x equals, you divide each side by 2. Divide it by 2, so negative 10 equals x. This one obviously has a solution, so this one is called one solution. All right, and the last one, you're going to do the same thing, distributive property. So 3 times x is 3x, 3 times negative 2 is negative 6, and then 3x equals 3x minus 6. You'll notice just like the first equation you had 2x on each side, but your constant was different. And this one we have 3x on each side, but our constant is the same. So let's see what happens. If I subtract 3x from each side, I have negative 6 equals negative 6. Is that true? Yes. So since it's true, this is called infinitely many. If you want to be lazy, like I sometimes am, no solution, the sign for that would be a 0 with a slash through it. And infinitely many, you can draw the infinite sign if you would like. So we're going to plug some values into each equation to determine whether or not it's true. So our first equation was 2x plus 4 and 2 times x minus 6. JK, plus 6. So we do our distributive property. Before we do distributive property, we're going to plug a number in. We're going to plug in 0. So 2 times 0 plus 4 equals 2 times 0 plus 6. So 2 times 0 is 0 plus 4, and 2 times 6, because 0 plus 6 is 6. So is 4 equal to 12? No, so it's no solution. Our next equation, 4x minus 3 equals 6x plus 8. If I plug 0 in for this, 4 times 0 minus 3 equals 6 times 0 plus 8. 0 minus 3 is negative 3. 6 times 0 is 0 plus 8. You get negative 12 equals 8. The problem is that's not what x equaled up above. So you can't just pick any value for this one. You actually have to use what x equals. So x equals negative 10 in this one, so we actually have to use negative 10. So 4 times negative 10 minus 3, is that equal to 6 times negative 10 plus 8? So 4 times negative 13, is that equal to negative 60 plus 8? Well, negative 60 plus 8 is negative 52, and 4 times negative 13 is also negative 52. So yes, x equals negative 10 is the correct answer, and the only one that will work. And the last one was 3 times x minus 2, is that equal to 3x minus 6? If we plug 0 in, because it didn't give us something to work with, 3 times 0 minus 2, is that equal to 3 times 0 minus 6? So 0 minus 6, is that equal to 3 times negative 2? And yes, negative 6 is equal to negative 6. No matter what you plugged into this one, it would end up being correct. So now we're going to look at some vocabulary. A null set is the same thing as no solution, which is the same thing as an empty solution set. So nothing would be true for a null set. What that looks like is this. Now, identity is any real number is a solution. So that would be the same thing as infinitely many. So the words for null set is no solution. The words for one solution is one solution. And the words for infinite, or for identity, would be infinitely many. The algebra representation for null set would be ax plus b being ax plus c. So notice how the number, the coefficient with the x is the same, but the constants would be different. For one solution, ax plus b equals cx plus d, where a cannot equal c. So the numbers that are the coefficient with the x are not the same. And finally, for infinitely many, ax plus b equals ax plus b. So they will have the same exact coefficient and the same exact constant. So an example of a no solution would be 5x plus 2 equals, 5x plus 2 equals 5x plus 7. Notice how it's 5x on each side, but a different constant. One solution would be like 3x plus 4 equals 2x plus 1. Notice how the constants are different and the coefficients. And finally, infinitely many would be 2x plus 5 is equal to 2x plus 5. Everything is the same across there. So some clues to look for a null set would be same coefficient. Remember, the coefficient is the number multiplied by x, but different constant. For one solution is different coefficients. That's what you're looking for there. And the last one is everything is the same.